Math 1, practice 2.7.1, building functions from context. So, we're making equations, explicit equations here. Remember, explicit equations connect the input to the output. Okay? And the way we typically write the input is with the variable x, the output with that function notation f of x. We could also use y. Okay? Now, the other thing to remember is our explicit equations for linear, straight lines, which remember it's addition over and over and over, so we would go f of x equals a plus b times x. Okay? And a, well, let's see, a is our start number, our y-intercept, or we could also call it the start. Okay? And our b is going to be the growth. In a linear, we also call that slope. But in an exponential, it's not slope. And our exponential is f of x equals a times b with the x as an exponent. So, basically what we need to do is figure out what, when looking at these, the best way to do it is to look for what's the start, what's the growth, and often making a table will help us see that. So let's kind of go from there. Mr. Ramos notices a pattern in the number of people attending the weekly student government meetings. For weeks 1, 2, 3, 4, and 5, the number of students attending the meeting was 31, 43, 55, 67, and 79 respectively. So let's make a table. Okay, so week 1, we had 31. That respectively tells us that the first number here and the first number here match up. So at 2 we had 43, 3, 55, 4, 67, and 5, 79. So we should be able to notice a pattern here. So to get from 31 to 43 we would have to add 12. Would that also get us to 55? Yep, so we're adding 12 each time. So there's our growth. Okay, b equals 12. Now, if we went backwards 12, so we subtracted 12, that would be what, 19? And there's our start. So we're adding, so we know it's linear, so I'd go f of x equals our start number plus the growth times x. And there's our explicit equation. Okay, number 2. Hannah borrows $30 from her parents. Each week she pays them back the same amount. The total amount she owes her parents after weeks 0, 1, 2, and 3, and 4 are 30, 25, 20, 15, and 10, respectively. So 0, 1, 2, 3, 4. So she started out borrowing 30. So there's our start number, right? And then how's it growing? Well, we go to 25, then 20, then 15, then 10. Should be able to see we're subtracting 5 each time, right? So there's our growth. So we go f of x equals our start number, and then this time minus our growth times x. Now you could write these all backwards and go negative 5x plus 30, same thing. Or 12x plus 19, same thing. Alright, 3. Angelo, or however you want to say it. Apparently I have to say it Angelo. Sells cookies in packages where each package contains the same number of cookies. The total amount of cookies he has after are as follows. So starting at 1, 110, 88, 66, 44, 22. So, do we see a pattern here? Subtracting by 22. So this would be 132. So our start number would be 132. And our growth would be subtracting 22. So we go f of x equals, so far all of these have been linear, haven't they? 132 minus 22x, right? We're just following up here where I'd written the linear version. Okay, number 4. Cameron tracks the growth of leaves on a tree in his yard. Each week he notes the number of open leaves on the tree. So, weeks 1, 2, 3, 4, and 5. We've got 12, 60, 300, 1500, 7500. Alright, hopefully you can notice that adding is probably not going to make this one happen. So we're probably multiplying. Well, how do we get from 12 to 60? We times by 5. Does 60 times 5 give us 300? It does. And so now our growth is we're timesing by 5. So we know this one's exponential, right? So going backwards, dividing by 5, we'd have 12 divided by 5, which can't really simplify. So that would be our start. So I'd go f of x equals 12 divided by 5 times 5 to the x. Okay, another way you could write that is if you really didn't like that fraction, you could go f of x equals 12 times 5, but then instead of being x, because you jumped up 1 to set you back to 0, you'd have to go x minus 1. But I prefer to do it this other way. Alright, let's keep on trucking. Number 5. As a treat, Nia eats a portion of a chocolate bar each day. She eats the same portion of the remaining bar each day. On day 0, she starts with 32 pieces. After day 1, 16. After days 2, 8, 3, 4, and 4, she has 2. So hopefully we can see the growth here as we're dividing by 2, or when we're dealing with exponentials, timesing by 1/2. So our start number is 32, and our growth is timesing by 1/2. So I go f of x equals 32 times 1/2 to the x. Number 6. Given the diagram below, describe the number of sides in figure x. Okay, so there's 3 here, 4 here, 5 here, 6 here. So if we went back to figure 0, we would have 2, right? So there's our start. How's it growing? We're adding 1. So I'd go f of x equals our start number plus 1 times x. Alright, looking at number 7 now. Given the diagram that follows, describe the number of blocks. So we have 1 block, then 3, then 9. So it should be pretty easy to see that we're timesing by 3. So our growth would be timesing by 3. Now our starting would be, if we went back, it would be 1 over 3. So we'd go f of x equals 1/3 times 3 to the x. Alright, number 8. A rural school uses a phone tree to reach parents when the school is closed. Each parent calls multiple parents to notify them of the school closing. Then they call multiple parents, and so on. So round 1, we have 1 parent, then 4, then 16. So it should be pretty easy to see our growth is timesing by 4. Now technically we'd have to jump back 1, and we'd go f of x equals 1/4 times 4 to the x. Now if you ended up just going 1 times 4 to the x and counted round 1 as the 0, that's fine too. Either one works. Number 9. A hotel charges a room fee per night plus an additional fee if more than one guest is staying in the room. Goodnight's hotel charges $150 per night for a room plus $25 per guest if more than one guest is staying in a room. Find an explicit function to represent the nightly cost for any number of guests. So let's think about it this way. So if there's only one of you, okay, so just yourself, it's 150. But then as you add one more person, we're going to add 25 to that, aren't we? 175. If we add 2, 200, and so on. So starting is 150. So f of x equals 150. And what are we doing to that? We're adding 25 multiple times. The population of a city is growing. Each year the population increases by approximately 10%, or 0.10 times the previous year's population. The population this year is 10,000. Find an explicit function. Okay? Consider that year 0 is this year. So we'd be at 10,000. Now we're growing by 10%. But remember, 10% of 10,000 is 1,000. So next year's growth would be that plus our original amount. So this represents 10%. This represents 100%. So we're growing by 110%. So we're timesing, turn that into a decimal, by 1.10 each time. So there's our growth, start number, So our function f of x equals 10,000 times 1.10 to the x. And there we go, guys.